As we know, binary is a base 2 system. Each bit in a binary number can hold two values. It can be on, represented by a 1, or it can be off, represented by a 0. IP addresses are 32-bit binary numbers broken into 4 bytes of 8 bits, also called octets. This number 192.168.10.1 would be a number that we would configure a client with. We would type in this number. The system, on the other hand, would see the binary number. So this octet right here represents 192. This is 168. This is 10. And this is 1. It's important that you're comfortable converting between binary and decimal. So in this demonstration, I'm going to convert the number 192.168.10.1 into its binary form. Remember, the key to being successful with converting IP addresses between decimal and binary is remembering the value of the bits. Each bit in an octet has a set value. From the highest order bit, which is 128, to the lowest order bit, which is 1. So what I'm going to do is turn on the bits that represent the number 192. 128 plus 64 equals 192. I'll zero out the remaining numbers, leaving them off. So 11000000 equals 192 in decimal. Next number we're going to look at is 168. 168, we'll turn on 120. 28 plus 32 is 160, plus 8 is 168, and we'll leave the others off. So there's 168 in its binary format. Next is 10. Turn on the 8, turn on 2, and zero out everybody else, indicating that we're leaving them off. And that's the number 10 in binary. And finally, number 1. Turn the 1 on and make sure everyone else is off. So there you have it. That's converting a decimal number into its binary form. The key to being successful with this is to remember that you have these 8 bits, and the value of those 8 bits, right, are static. So highest order bit will always be 28, followed by 62, 64, followed by 32, and so on. An IP address by itself is not very helpful. What we need to really use an IP address is 2 things. We need the IP address itself and the subnet mask that goes with the IP address. It's the subnet mask that tells us which portion of this address is host and which portion is network. Wherever you see the 255, you know that you're dealing with the network portion. So here, 192, 168, and 10 are masked off as part of the network. The only open one we have is the last octet. That's the octet where our host will reside. So this is network, this is network, this is network, and this is host. That's important because it's the host octet. Whatever host octets we have, those are the octets we can use to subnet addresses if necessary. Remember, by default, this address produces one network with 254 hosts. Now, this is the decimal way of looking at this. And here's its binary representation. As you can see, we have the IP address up on top and the mask. The mask, once again, is showing us which part of this is network. So we can clearly see that 192 is part of the network, 168 is part of the network number, and 10 is part of the network number. This octet is open. The client's address is 1, but it is open because it's not part of the mask. And that allows us to manipulate the bits in here to create more networks. So as it stands right now, what we have is one network, and the network number, remember, when it comes to network numbers, it's always the first possibility in the host range. So 192 is set, 168 is set, 10 is set. This octet is open. It's the first possibility in this host octet that will define our network. So in this case, 0 is the first possibility. So our network number, the subnet number, is 192.168.10.0 with a /24 mask. Remember, 8 bits on, 8 bits on, 8 bits on equals 24. The last possibility in this host range will be the broadcast. Well, the last possibility in here is if we turned all these bits on, and all bits on in a host range equals 255. So 255 is the broadcast. So 192.168.10.255 would be the broadcast. It's really important when calculating IP addresses that you always remember that you must subtract 2. And this is the reason you subtract 2 from the host range. Because 1 must go for the network and 1 must go for the broadcast. The hosts are in between. So our host numbers are going to be 192.168.10.1 to 10.254. Those are the numbers that we actually configure. Next, we're going to look at some examples of subnetting a Class C and a Class B address. Now, as we're going through this practice, I want you to always be asking yourself 4 basic questions. First one, how many bits do I need to borrow? Remember, a default Class C is one network with 254 hosts on it. If we want to subnet that and break it up into smaller networks, right, we have to know how many bits we need to borrow to accomplish our task. Next question is, what are the valid subnet numbers? 192.168.10.0 in the last example was the network number. We need to be able to identify the network number and the broadcast and the host on each of the subnets. So what are the valid subnets? And then what is the host range for each subnet? You need to know where your hosts begin and where your hosts end. And finally, what is the broadcast address for each subnet? As you're going to see as we go through this, it's not really difficult to pull that information out once you know a couple of tricks. In our first practice session, we're going to be looking at creating 2 networks. And first thing we're going to look to see is how many bits we need to borrow. Right? What are the new network addresses? Then we're going to identify the host range and what's the broadcast. So as you can see, I have a router in this little scenario that we have here. That little icon right there will represent the router. And what we're going to do is add two networks. So we're going to take this default class C address that we have and subnet it into two networks. Now, the first thing that we need to do when trying to accomplish this is to realize that we must borrow bits. So what I've done is taken this class C default one network. The mask is 255.255.255.0, and I've broken out the last octet and the 8 bits and their corresponding values. So we're going to have to borrow bits from this host portion and tell the system that we've done that and create our multiple networks. So how do we tell the system that we're borrowing bits? You tell the system that you're borrowing bits from the host portion by changing the mask. So like I said, the default mask that we're dealing with here is 255.255.255.0. That's the default. What we do to tell the system that we're borrowing bits is modify this last octet, because that's where we're taking the bits from. So we're taking bits from the last octet and we have to modify the value of that octet in the mask. Other critical thing to keep in mind when subnetting is that you must always borrow from the high order bit to the low order bit. So left to right. Whenever you're dealing with networks and you're borrowing bits for subnets, the rule is left to right. You start from your left highest order bit and work your way down to your right. So this is networks. That's different than when we're borrowing for host, which we will be doing. When you're looking to protect host bits, which we'll be looking at later on, it's actually the other way. So you go from low order to high order, borrowing from right to left when you're dealing with hosts. The first couple of examples that we're going to look at are going to be all borrowing bits for networks. We're going to look at how do we create networks. Later on, we'll look at protecting hosts, and this becomes very important when we get into variable and subnet masking, as you'll see. We have to create two networks. Well, the first question you ask yourself is, how many possibilities in a particular bit? So we know it's binary, so it can have two possibilities in a bit. That bit can be on or that bit can be off. If we have 2 bits, remember it's powers of 2. So you're basically just multiplying by 2. If we could have 2 possibilities here, in 2 bits we could have 4 possibilities, and that would look like this. Both could be on, both could be off. This one could be on, this one off, this one on, this one off, and that's it. That's all we have. We can't create any more. And if we went to a 3rd bit, 2 to the 3rd, right, equals 8. So we would have 8 possibilities that we could work out. So the first question you have to ask yourself is, how many bits do I need to borrow to create 2 networks? And when you hear networks, you can also think possibilities. So how many possibilities in a bit? 2. How many bits would I need to create 2 networks? 1 bit. So I'll need 1 bit, and what I always do is draw my line. Once I've decided on how many bits I need, I draw my line. The number to the left of the bit becomes very important. The number to the left, this is now going to become part of the network, and everything else from here on down is going to be host. So once again, draw your line. We know we need one bit. We draw our line. Now that's important because it also tells us what increments our networks will go in. Now when working with this, the key is you will always start with 0. Always. Whenever you describe your networks, the first possibility in here is 0, right? It's not on. So 0 is actually going to be our first network number. So the first network would be 192.168.10.0. Now, how do we tell the system that we've borrowed that bit? We tell the system that we've borrowed the bit by changing the mask. Our default mask was 255.255.255.0. Well, I want to tell the system that I've just borrowed that bit. Well, what I do is I take the value of that bit, which is 128, and plug it in and replace the 0 with it. So 128 would be our new mask. So 255.255.255.128 is our new mask, and that tells the system that I have borrowed that bit and I'm now using it for the network portion. Two networks are going to be the first one, which is always 0. So 192.168.10.0. And the next network is going to be 192.168.10.128. Notice, another reason I draw the line, the number of the rightmost bit that you borrow, the lowest order bit that you borrow, is also going to tell you what increments your networks go in. So we have two possibilities here, right? So in one bit, two possibilities. Two possibilities. First one's going to be 0, going in increments of 128, 128. So 0 is the first network number, and 128 the next network number. So it really is critical. Draw your lines. Once you find how many bits you need to borrow, draw your lines so you know the exact increments of your networks. And also it helps you because then you can add up your mask too. So once again, let's take a look at that. I have the first network of 192.168.10.0 with a 255.255.255.128 mask, or another way of describing that, remember, would be a /25, because 255.255.255 is 24. There are 8 bits on here, 8 bits on here, 8 bits on here, and then 128, of course, there's 1. 8 plus 8 plus 8 plus 1 is 25. So another way of describing it is a /25. So that's my first network. What I need to do is find out where's the broadcast, because once I find the broadcast, then everything in between the network and the broadcast is going to be host possibilities. And it really is easy to see your broadcast. The only thing you need to do is write out your networks. So the increments of your networks, how many you have and what increments they're going to go in. So we have 1 bit, 2 possibilities. They're going to go in increments of 128 because that's the number to the right of the line, to the left of the line, I should say. And so our next network is going to be 192.168.10.128. Now that's important to write that out because that tells me where the broadcast. Here's a rock solid rule. The number before the next network will always be the broadcast for the previous network. So for instance, this is the 0 network. The next network is 128. Following that rule, the broadcast for the 0 network would be 192.168.10.127. That's the easiest way to remember it. The number before the next network is always the broadcast. Remember, what's the rule for the broadcast in an IP address? The rule is all bits must be on in the host range. Now remember, we've just taken this bit for network, so it's part of the network now. The host bits are over here. Here are the host bits. And I'm saying that 127 is the broadcast for the 0 network. Well, if we turn these bits on and add them up, we should come up with 127. So we have 64, 96, 112, 120, 124, 126, 127. All bits on in the host portion is broadcast, and all bits on in the 0 network, what's left of the 7 bits, equals 127. So this is the broadcast for the 0 network. The hosts are going to fall in between those two numbers. So our host range is going to be 192.168.10.1, so it'll start out with 1 and go to 126. Those are the last two host numbers that we can have on this network. The 128 network, the other network in our little scenario, its broadcast is going to be the last possibility. And the last possibility in an octet, since it's the last network, is always going to be 255. .255 is the broadcast for the 128 network. That means that the first host will be 129, and the last host will be .254. If we were to look at this and include our little router in here and draw a couple of sections, over here we'll draw one end, and over here we'll draw the other. What I'm going to do is assign addresses, put a client over here and a client over here. This is going to be the .0 network, and this is going to be the .128 network. So what I would do is take the information that I have here, including my new mask, and plug it in over here. Since you always, well, I shouldn't say always, but it's just good form to assign the first addresses within a range to important devices. The most important device we have here on these small networks is the default gateway. This interface right here will be the default gateway for the 0 network. So I'll give it the IP address of 192.168.10.1 with a /25 mask. Now remember, it's important to include the mask because without it, that's a default class C. And this client over here, we'll give them a number somewhere within the range. And so we'll use a number like 192.168.10.11. We'll leave the first 10 numbers or so for other devices, whether they're servers, printers, that we think are important. On this side over here, this is the 128 network. So the first number I can assign to this interface on this network would be 129. So I'll give that interface of the router, which is the default gateway, 192.168.10.129, the first number on that network. And once again, I'll assign the client over here something in higher range on that network. So this client will be 192.168.10. Let's just say 35. I've taken this default class C address and now broken it into two networks. What I'm going to show you next is actually that this does work, and it is important. This device here plays a critical role. Once we start breaking up networks, we need a router. We need to tell clients how to be able to get back and forth across the network. So when they want to transfer packets, they will go through this device to get there. To demonstrate how this is used in the real world and how you configure devices with subnets, I have two virtual computers that I've set up. By default, they both have the default mask and IP address. So there's two of them. Put one over here for now. So let's go take a look at the IP address configuration. So I have the default class C, the same number we were using in our scenario. So this client is 192.168.10.25. And this client is 10.168.10.133. They're both on the default Class C network, so they see themselves as being on the same network segment, the same subnet. I'm going to demonstrate that they can communicate, so I'll ping from here to the other host, and what we see are replies coming back. And if I type netstat, right, we can see that the client sees itself as being on the 192.168.10.0 network. The other client is also on that network. But what I'm going to do now is take the IP address scheme that we worked on and put these two clients on separate networks and see how the dramatic changes take effect. So let me close this. And all I'm going to do is just go into my network settings. And I'm going to make one simple change. I'm going to change the last octet from 0 to 128. And I'm telling it by doing that, this client is now on a separate network. Or it's in this case, this client is on the 128 network. Remember, they go 0 to 127, 127 being the broadcast for the 0 network, to 128 to 255. So this client sees itself as being on the 128 network. And we can verify that. netstat-r, and sure enough, there it is. The client sees itself as being on the 192.168.10.128 network segment. So let's go configure the other client. Remember, they had no problem pinging just a few minutes ago, a few seconds ago actually. So once again, I'll change this to the 128. Now remember, it's this number, it's the client's number that tells it, that tells XP how to configure this. The other computer was 133, so when I typed in 128, it immediately calculated, oh, you're on the 128 network because your number is higher than 128. In this case, it's looking at this 128 mask and going, oh, you're on the 0 network because your number is lower than the 128. Remember, there's two segments. So that's all I have to type in there. Just change the mask and it changes everything. Once again, we'll take a look at this client. And this client sees itself as being on the 192.168.10.0 network. But that's the mask, that's the key. You know that this client sees itself on a different network segment than the other client. So what we're going to do is go back to this client and ping. It was successful before, so 192.168.10.25. That worked when they were both on the default Class C mask, but now that I've subnetted it, what I'm going to get is nothing. Because these clients now see themselves as being on two separate networks. And what they'll do, they'll literally look at their mask, compare it to their IP address, compare the destination IP address and the mask, and to see if it's on their network, and if it's not, they'll send their packets to the default gateway. And that's what's happening. Right now, they're both sending their IP addresses to this gateway, and by the way, this gateway does not exist. I just plugged it in there. But they're literally on the same cable. As a matter of fact, because this client did communicate, oh, nope, it washed it out. I was going to say, many times in this little scenario, you'll actually see the ARP address of the other client, but it doesn't see that client as being on its network. It calculates it and sends it off to the default gateway. So this is the importance of having a functioning router. Like we saw in our little scenario, our little diagram, the router is an integral part of this. And we're going to see that as we go along, because we're going to take this theory and bring in routing protocols into this and set up routing. But this is a perfect indication of just how important this is. I'm going to set them back to their defaults, and then we'll test it again. So back to 0. Once again, that's the only thing I'm changing. Back on this one. Back to 0. Flick back over to this client. Go to the run line. And we're going to ping 192.168.10.25 again. And sure enough, they now see themselves as being on the same network segment. So you see just how powerful it is when you can actually manipulate the network portion or the bits and create more of these networks. Okay, let's move on to example number 2. Now the scenario is that we must create 3 networks. We ask ourselves the same questions. The key, once again, to start it out is to know how many bits you need to get 3 possibilities. Remember, possibilities, networks, they're the same. Well, we know in the last scenario borrowed 1 bit for 2 networks, so obviously we're going to have to borrow more than the 1 bit. And just keep in mind everything is powers of 2. 2 bits or 2 to the second will provide us with 4 possibilities, which means we're going to have 4 possible networks. I brought in another router here, right, to expand upon our network, because we're going to create a segment between the routers for this particular scenario, and then 2 LAN segments. How many bits do we need to borrow? We need to borrow 2 bits because we need at least 3 networks or 3 possibilities, and we need at least 2 bits to get that. So what we're going to do is draw our line. 1 bit, 2 bit. The 64th bit is the bit that we're going to draw our line between. That and 32. Now once again, this bit and the line become very significant because that's going to tell us what increments our networks go in. So in this case, we've gone over 2 bits. We're at the 64th bit, and our increments of networks are going to start at 64. So our network will, first network number, and it's always the first network number, should always be your answer if I ask, is 0, right? That's the first network possibility. And after that, it's going to go in increments of 64. Now, the key, once again, is we have to tell the system that we've borrowed those 2 bits. Now, in the last scenario, we changed the mask from 255.255.255.0 to 255.255.255.128. We're going to do the same thing here. All we're going to do is take these 2 numbers and add them together. And those 2 numbers together equal 192. So our new mask for this to tell the system that we're borrowing it is going to be 255.255.255.192. That number tells the system that we borrowed the 128-bit and the 64-bit for networks, and we've masked it off. So our networks are going to go in increments of 64, right? And there's 4 possibilities. So 0 is 1, 64, 128, and 192. Now notice, it's kind of interesting, and this only happens in Class Cs. The mask was 255.192. The last possibility, right? Remember, there's only 4. The last possibility just happens to match. So 192 in the mask, 192 in the last possibility. Once again, that only takes place in Class Cs, but it is nice in the beginning to see that. Okay, next we have to define the broadcast for each of these networks. So this is the .0 network, this is the .64 network, this is the .128, and this is the .192. What is going to be the broadcast for the 0 network? Well, remember our rule. This is the next network number right here. So 64 is the next network number. So the number before that is always going to be the broadcast for the preceding network. So 64, which means 63 is going to be the broadcast. Once again, look at 64. 128 is the next network. 127 is the broadcast. 128 is the next network. 192, okay. 191. And of course, the last network will always have 255 as the broadcast. So there you go. There we've broken out our 4 networks. We have the network number, and we have the broadcast number. Now, everything in between these numbers is host. This is what we can configure. This is going to be 1 to 62. This is going to be 65 to 126. 29 to 190. 193 to 254. Right in here, this is the host part. This is the part we can configure, and the system calculates the other two based on what we've done. So now let's take it over here and let's start configuring our network. So what I'm going to do is create a connection between these 2 networks. So that's going to be the connecting line between them. And then from there, we'll also have network segments. So we'll draw another line. Draw it out here. That's a network. And that's a network. Just picture it being a line, lots of computers over here. So what we want to do is assign addresses that will allow us to communicate across these networks. So what I will do is I'm going to take the first network, number 0, and I'm going to assign it to this network over here. This network over here, we'll call it LAN A, or LAN 1 maybe. LAN 1 is going to be the 192.168.10.0 slash, what is that going to be now? It was a /25, so it's /26. Remember, 8 plus 8 plus 8 plus 2. So it's going to be a /26 over here. Then I'm going to go over here and assign 1 also. Well, it's interesting. I'm over here, but really, right in here is important because in here, this little spot right in here is a network. Whether it's a serial connection or in this case, it could just be fast Ethernet between 2 small routers. That is a segment that I have to address. And so it has to take one of these chunks. So you know what? I'm going to assign the 64 in here. Let me erase that. This, but just between these 2, now it's interesting. Over here, we have lots of clients. Over here, we have lots of clients. In between these 2, we have 2 connections, but they still, based on this type of subnetting, have to take a whole range. So I'm going to give it the 64. So I'm going to say this, that between these 2 is 192.168.10.64 with a /26 mask. Now once again, understand the ramifications of what I've just done. There are 2. There's 1 and 2. Consider them hosts, if you will. So there's 1 host and 2 hosts. That's it. That's all there is between a point-to-point connection between these 2 devices. What I've done is basically taking this whole section here. Now this goes from 65 to 126. That's 62 possibilities in here that I've eliminated. So that whole segment is gone because I had to address it here. And that's definitely a possibility. Well, it's definitely a problem, I should say, because we've lost a heck of a lot of addresses within our range. That is not a good allocation of addresses. We're going to see, once we get past this part, how we can better allocate, more efficiently allocate numbers with variable length subnet masking that will take care of this. But for right now, this is what we have to do. This is the scenario we have. And then, of course, over here, I'm going to assign the next network. So I've assigned this one already. I've assigned this one. I lost a heck of a lot of addresses in there, and I've assigned this one. Well, I'm going to. So this one is going to be the 192.168.10.128/26 network. I've allocated 3 of the 4 possibilities. This one we'll just leave in reserve for later on. So over here, we have a network segment that could have 62 hosts on it. And over here, we have a network segment that can have 62 hosts on it. And unfortunately, over here, we only have 2 hosts, and we've wasted 60. Wasted 60 possible addresses. But in this scenario, that's how we had to do it. So that's example 2, creating 3 networks. So far we've been working with Class C address and the subnetting Class C addresses. And as you can see, it's not difficult as long as you follow a few rules. Class Bs, while they can seem intimidating at first, are really no more difficult than a Class C once you accept the fact that you're working with more bits and you have a second octet to think about. The key for me to subnetting a Class B address is asking myself 4 basic questions. First one is, what subnet am I working with? What is my first host? And then you can ask yourself, what is your broadcast if you prefer? That might be one way of looking at it. Or you could go and ask, which is your last host? Either way, we'll look at both of those examples as we go through, but those are the last 2 questions. Once you've answered that and gone through this process a few times, you'll see that subnetting a Class B is not that much different than subnetting a Class C. Okay, so let's go ahead and do that. Let's get a Class B subnetted. And what I'm going to do is we're going to select that we need 4 networks. We'll start out easy. So 4 networks. Ask yourself, how many bits do I need for 4 networks? We know we've been working with this in the Class C. Now the key with this is that we're not working with this octet over here. This octet over here is going to be ignored. We're going to be working with this octet. The 3rd octet as opposed to the 4th octet. So when you're asking yourself those questions, what you want to make sure your answer is within this 3rd octet. More advanced applications, of course, can go over into borrowing bits all the way into the 4th octet, but we're going to look at it from this perspective. Once you have this, you can move on to more complicated scenarios very easily. Once again, we have 4 networks that we're looking for. 4 networks require 2 bits. 2, 4. I'm going to draw my line, as I always do, and that defines what increments my networks are going to go in. 64. Nothing has changed. We're just in a different octet. So my networks will go in increments of 64, so I'll write those out like I always do. 0, 64, 128, 192. Stop. Those are our network numbers. Let's start with the first network. The first network number is going to be 172.16.0.0. Remember, we're ignoring this. There's nothing going on here. So the octet of interest is that third one, and everything always starts with 0. So nothing has changed. The first host is a little bit different because, once again, we have so many bits that we're working with. It can seem a bit intimidating, but it really is not. The key is to remember that host bits are always calculated from right to left, low order to high order. And if you remember that, then you'll realize when doing that the first host has to be 172.16.0, nobody in there, not yet, 1, because we have to turn on that bit first, all the way down here. This is the interesting part, and this is where most people, when they first look at it, don't understand how you figure it out. Once again, the rules have not changed. What's the rule? The rule is the broadcast number, the last number in this range, is going to be the broadcast for that network. Right? The last number within this possible range, so it's the number before we get to 172.16.64.0. So it's going to be the broadcast. And what's the rule about broadcast? Ask yourself, what is the rule in a Class C about a broadcast in the host range? The rule is all bits must be on. So we know this is the host range right here. All we have to do is turn on all bits. It's on all bits, and then the question, this last one, what is that? When you turn on all 8 bits in a number, what happens? It's 255. So write in 172.16 dot and leave it blank for a second, dot 255. Well, what number is before 64? 63. That's the broadcast for the 0 network. Well, having said that, what's going to be the last host? Well, the last host is going to be the last possibility before the broadcast. And so that is, if we take this one off and make it a 0, we end up with 172.16.0.254. That's not difficult at all. As long as you remember the rule about getting your broadcast address, to me, that's probably the key. Find your broadcast, turn all those bits on, look for the number. So in the next case, it's going to be 127. So immediately you can look at this and go, well, the broadcast is going to be 127.255. The broadcast for this is going to be 255.255. That one is a little bit different, and we'll look at that one. But let's go on and do the next one. We're going to start all over again, and we're going to move down a range. Actually, I should have left it right there, but we know our networks are going in increments of 64, 0, 64, 128, 192. We're going to look at the 64 network next. So we've taken care of 0. 0 is done. So it goes from 0.0 to 63.255. That's the number before that next network. So you're seeing that it could get pretty easy at this point. Once you have that first one down and you realize the rules haven't changed, you can pretty much you know what the broadcast is going to be now for the 64 network and for the 128 network. The tricky one is the 192, which definitely looks peculiar when you first see it. So let's go for the 64. Subnet number is going to be 172.16.64.0. Right? The 64 network, we're interested in the third octet. That's the octet of interest. We're going in blocks of 64. We've done 0. We're on 64. Now, the easiest thing to do is just to find your broadcast. Once you have the subnet and the broadcast, you can easily see the first and the last host. What's the broadcast going to be? Well, if we look at this, it's going to be 127.255, right? Because that's going to be the next number, right? It's going to be all bits on. Remember, we turned all bits on over here. 127 is the next number, all bits on in the host range, 255. Easy. So 172.16, 127.255. Now it's a matter of just fill in the blanks. And that's 172.16.64.1 and 172.16.127. Right, the number before 255, 254. Done. So we've done this one also. So this is .64.0 to 127.255. Well, you can see this one right here is going to be pretty easy. It's 0 to 191.255. Not difficult at all. The one that's a little strange is this one right here. So let's clear off some of this. And it's strange because when doing Class Cs, we're so used to the number 255 in the host range means broadcast. And yes, we've burnt that into our minds, but we have to understand the main rule is all bits on in the host is a broadcast. The last possibility in here, we could put the broadcast down in here. It's going to make it easy, so we can do that. It's just going to look weird when we do it. So we're going to put .0 to 255.255, right? That's going to be the last. That's the broadcast. That's always 255. 255 is, or 255. It doesn't. It just depends on what class of address you're working with. But the last broadcast and the last octet will always be 255s in some fashion. Well, if that's the case, if we can come over here and go 192, 192, I'm seeing that now. I'm going back to Class C's myself. Okay, how about 172.16 dot, what is it now? 192.0, and the broadcast is 192. Oh boy, I got 192 on the brain here, huh? Alright, let's try that again. How about 172.16.255.255? Okay, so what's going to be the first host, you ask yourself, and that looks pretty normal. 172.16.192.1. That's the first host. And then we look at the broadcast and we go, wow, the answer to that has to be, since it's the number before this number, the answer has to be 172.16.255. That's weird. .254. That's the one that's always strange. When dealing with Class Bs or Class As and you're subnetting them, realizing that you could end up with a 255 and not actually that be wrong is a little peculiar at first. But it's correct, because once again, if we that last number 192, the last possibility in this range is going to be all of these on, and after 192 turning all of these on is 255. And the rule is the same. We turn all the bits on in the host if we want to broadcast, and the last possible host number will have 1 bit off. 172.16.255.254 is the correct last host on the 117.16.192.0 network. That and this little formula here, making sure that you're asking yourself these 4 questions and preferably answering the first and the last, right? So if you can do that, that's ideal. But once you get one done, even if you have to work through it from top to bottom, once you have one done in a range, you can pretty much tear through the rest of the Class Bs as long as you remember that last host in that last network range is, if it's a Class B or a Class A, going to have a 255 in an actual host number. The last octet, of course, will not be 255, and that will be the key to knowing you're still dealing with the last host and actually a assignable IP address. That's Class B subnetting, and it doesn't change no matter where we move that line. We could go down, we could go back up again, we could take 1 bit, we can take 4 bits. It doesn't change. It stays the same. So let's try it one more time. We'll move a bit along. Okay, this time I'm going to say that I am going to need 8 networks. So draw my line as I always do. Draw my line. My increments are going to go in increments of 32. So I'll write it out. 0, 32, 64, 96, 128, 160, 192, 24. So there's our 8 possible networks. So we're going to look at this and we're going to just follow our rules. And the easiest one to start out with is the first network. So the first network number is 0. So our number is going to be 172.16.0.0. We could look immediately at this. Now you know the rule. And you can see it in a Class B format. That's the key. You know all bits on over here has to happen for the broadcast, and that's 255. So then I just look at 32 and go, what's the number before that? Oh, it's 31. So that means the broadcast is going to be 172.16.31.255. Everything else, a piece of cake after that. 172.16.0.1, 172.16.31.254. Right. Again, not any different, and we could pretty much tear through the rest of these as far as ranges go. 31.255, and this one's going to be .0 to 63.255. See what once you have it down, it's the same with the Class C. Seems complicated at first, but once you answer the first few questions and you realize where that broadcast address is, it becomes very, very easy to answer the questions. And of course, the last one is going to be the weird one. The last one will be the strange one. But we know that .0, once we do that, even that's not that peculiar. It just takes a little time getting used to it. First number, first subnet, 172.16.224.0. Broadcast is 117.16.255.255, which means the last host is the number before this one, which means it's 172.16.255.254. And the first host is, of course, 172.16.224.1. Not bad. Once again, practice this. You can copy what I have here. Your book, chapter 3 or chapter 4 in your book, goes into this. He uses this formula. It's so simple, but it works. And you can literally do this in your head, just as he says in the book. Takes practice, absolutely, and yes, you'll forget it. You'll forget it if you don't use it on a regular basis. But once you see it again, it'll pop right back in. And as you can see, it's not difficult. Okay, in the next section, we're going to be looking at variable length subnet masking, and route summarization.